As usual, waiting to be live. There we go, I should be live. Hello everyone, welcome back to the project. I have a tiny bit of time this weekend, this evening, I mean, so let's make some progress. Especially since yesterday we finally got to a point where the refactor is compiling, which means I should be able to merge the branch back into dev and to resume working on the actual features of the compiler. What I want to do this evening is going to be a short stream, I think. What I want to do is to start testing things manually at the very least some manual tests to make sure that we haven't lost too much in the refactor. And uh, past this, when I'm done fixing a few bugs in the things that I like finding, testing things, fixing bugs, there are a few features I'd like to fix. I'd like to address. I've disabled the pretty printer at the moment because as part of the refactor, it would no longer work. That's one thing I'd like to fix so that we can re-enable some tests. I'd like to do some cleanups, and I have a list, and I would like to also another thing that I wanted was to re-enable the simplification phase that we no longer have. So that's the plan for this evening. So to get started, yesterday by trying to compile those things, we found a few interesting bugs. The first being if I have a cycle in constants like this, where A is defined in terms of B, B is defined in terms of C, C is defined in terms of A, the error that we get a cyclic error definition for all three of them, where we get, where is it? Cyclic definition, there we go. And we get three cyclic definitions. And we get one for A, one for B, and one for C, which is not great. So something is wrong here that we're gonna have to fix. And also the list is supposed to contain the full thing and does not. So something is wrong in the way we emit errors for cyclic definitions. So that's one thing we're gonna have to fix. Another thing is here this function is generic, and therefore its definition is like it only contains the type. Let me comment a few other things to showcase what I mean. Here, the function b1 has a definition as part of what the module exports, but it should also have a copy of it in function that is going to be used for when that function is instantiated in another module, and that is missing, so that's another thing we need to fix. And here I had a few other tests. For now, since we don't have dynamic size types because vectors and arrays and things like this are not handled yet, for now we allow structs that cannot actually exist. For now, a struct foo that contains a field of type bar, where bar is a struct that contains a field of type foo. This is accepted by the compiler at the moment. We don't have an error for this. Another thing I've tried quickly off stream, but I didn't write any code, just this one test, was a type alias like this, where A of t is just t, B of t and u is A of u, C of t u v is B of u and v. And I tried here, and this function here, this key smash here, takes an argument of type t and returns a value which is a C of t character and boolean. And if we look at if we run this, and if we look at the definition of this function here, that's the F1, that's this one. Its return type is labeled as being a Boolean because the type alias has been correctly replaced. And that's one thing I also want to do is I want to remove, currently the lookup of type parameters assumes that we won't do the substitution correctly and we carry some type information that is no longer required. That's a cleanup I want to do this evening. Now, there's a few more things I'd like to test, I think. At the very least, I'd like to check What do I want to check? I probably want to check expressions. Function calls would be nice. Let's do, for instance, let's imagine I have a function plus that takes two ints, returns an int, and returns x plus y. We have minus that does x minus y. That's going to be a test first. Those two should compile. I want to try function pointers, which are complicated, just to see if this works. How would that work? I can try test function pointers. A function that takes two ints, x and y, there again, and returns an int. And it's going to take also some add, which is going to be a boolean. And let f equals plus. Or let's minus if add f equals plus, return f of x and y. Will that compile? Will that give me an error? Not implemented yet. Haha. Unimplemented at stages validation expression. Okay, let's go see what this is. Oh. Oh, we didn't do the validation of L value expressions. Well, I guess we can do that now. I thought we had done that, but I guess we skipped it as part of when doing the refactor, and now it's broken. Okay. So, what do we do here? So this is part of the analysis phase, and specifically this is part of the validation subphase. We've already resolved the expression, so we know what the names point to within this. And we're trying to say, well, we expect this thing to be an L value. So this expression that we have, that has been resolved, we must return this as a typed L value expression. And an L value expression, if we look at validated, that's a subset of expression. We have const expression that is also a subset. L value expression is basically a tree. A variable is a valid L value expression. A reference to a function argument is a valid L value expression. And otherwise, a field access expression is valid as long as its left-hand side is itself an L value expression, and an index expression is also a valid L value expression if it's indexing from something that is a valid L value expression. So if I have a variable a.x is a valid L value expression, but function call.x is not. So that means we need to handle that kind of stuff. This is going to be very similar to how we validate. This is going to be extremely similar to how we validate those in the regular case, I suppose. How do we validate a function path expression? Okay. Let me copy this. So it's going to be an L expression there. And, well, we can do a few things already. A built-in function will never be a valid L value, so it's not something we have to handle. A function will never be a valid L value, so that's not something we have to handle. A constant will never be a valid L value. That's not something we have to handle. You can't assign to a constant. So function argument and let variables are two. If we ever encounter a thing that's a path, that's the only things that are valid as far as a L value expression is concerned. So if we have a function argument, so I can remove all of those others. Validate function path, that's no longer required. There we go. I will need to introduce a new error, unless I already have one. Assignment. Do I have a message for assignment? Error R value assignment, I suppose. So that would be here, error R value assignment. It's not a great name for this error, but basically, well, I mean, that's just a code. We'll decide how the error is written down the line. But basically, this L value that appears on the left-hand side of an assignment is an R value, is not a valid L value. That's the meaning of this. So this is going to be a validated L expression or L value expression. What's the type again? L value expression. In the case of a variable, we get the variable type, and we return it's a typed expression of the type of the variable, and it's the local variable L expression of the variable name, because, yeah, here again, the name is all we need. And those should mirror basically the constructors of expression. I don't think I care about index at the moment because index is not supported yet anyway. We don't have arrays yet, so I don't really care about it. So I think the only thing I care about otherwise is field access expression. Oh, I also need to do the argument. So it's just exact same thing, except those are the L value constructors. Yeah, and I think everything else is not required. So that's validating the path of an L expression. So here in this function here, this is now validate function path L expression. And the only thing left to do will be here. Oh, I already do R value assignment here. That's fine, I think. Well, no, it's not. It's not. Okay, because this error code, R value assignment, is indeed something that expects an expression. So I will want a different one for when I have a roll that's incorrect. So I will want something like not an L value, which is what I'm going to use in the functions we've just defined. Not an L value. Okay. For field access expressions, what do? We do validate function field access expression in the case of a function. Let's do the same thing in the case of an L value expression. So this is going to be an L expression here. Or actually, let's say L value expression to be very explicit. Which means this one here is renamed to L value expression. There we go. And we are going to copy the one that we have for field access. Validate function field access expression. And we're going to rename this to field access L value expression. There we go. And we might be able to simplify some of this, or maybe deduplicate with some of this. Let's see. Because here in this case, the validated expression on the left-hand side must be not a function expression, but a function L value expression. I don't have... I don't have... How is it called then? Oh, it's called L value expression. I don't qualify it as function because those only appear in functions. That makes sense. So that would be validate L value expression of the expression on the left-hand side. It must be an L value for a field access within it to also be a valid L value. And it must then be a struct. If it's anything else, error, not a struct. Okay, perfect. And if it is a struct, we get the struct information from the base name. We do all the parameter mapping. Okay. This retrieve struct. Yeah, now that makes sense. The assumption here is, since this is an expression on the left-hand side that has a type struct, it means, and I am in the context of a function, it means it is a concrete type. It must be a concrete type. There is no way for it to be an incomplete type at this point, a generic type. So we can just reify types on all of the fields. Then find the field. If we don't, then we can just field access field not found. Like I try to access field X in a struct that doesn't have a field X. And the result will be pure typed field. Yep, that looks correct. And this is a field access L expression. And I'm just going to check one thing, which is here we have the struct info, the typed L value expression, and the identifier. And for a normal expression, we have the struct info, the typed expression, and the identifier. That seems correct. Okay, perfect. So it's exactly the same thing as this, to the point that I might want to deduplicate some of this. Because they do the same thing. The only difference that I see is what function do we call... Hello, how are you? What function do we call recursively to analyze the left-hand side? Everything else is the same. And then the only difference is we use a different constructor at the end. So yeah, those functions are twice the same. I think I'm just going to want to deduplicate them, because there's no point in keeping it twice I guess there's a point in keeping it twice, just because if they end up diverging, it's easier to have them already split. But there should be no reason for them to be different. It's just that we have checked. Yeah, no, I think I should deduplicate them. Okay. So I'm just gonna name the common one validate function field access. And this one is gonna take 2 extra arguments. Actually, it probably doesn't need to. Yeah, instead of here taking the with location resolved expression, it's gonna take a typed E, which is a kind of expression, and this is the same kind of E that's gonna be returned here. And we are gonna need a function we are going to need a function, which is going to be the constructor we call here at the end, which is going to be something that, given a struct info, that is using concrete types, and that one expression, actually the typed one, and a field name, I think that's about it, which is an identifier, will give us the resulting E that we can call, that we can return at the end. So that's our constructor at the end. And it comes before the expression. Okay, so we remove this line because we're gonna get it directly here from the types thing. So that's our validated exp. When we do not have a struct that is error, not a struct, everything here remains the same. We do find a struct, we retrieve the struct information from the base name. Param mapping hasn't changed, validated field hasn't changed, finding the field name hasn't changed. The error, if the field is not found, is the same error. The only difference is here, rather than this being validated field access expression, we call the constructor with, I guess I could introduce for readability, concrete struct info is going to be, or validated struct info to be consistent. It's going to be this. And we're going to give the constructor the validated struct info, the validated expression, and the field name. That is, so that's this, and that will be our result. So now, in the case of an L value expression, we validate function field access with a function which is validated field access L expression. I think that's the one. Field access L expression. Yep. So that's the constructor to use to construct the result. And the value, the validated value, will be the result of validate, and I write it the other way around. Validate L value expression. So here we have the expression and the identifier that we have named field name. So we validate the L value expression of this expression. Oh, I'm tempted to change the order here because it's going to be a bit easier if I do. Nah. Let's keep it the same. Let's not use any fancy operators. Let's be a bit more explicit. The validated expression is the result of validate L-value expression. And the result of our function is to call validate function field access with this constructor, the validated expression, and the field name. Like, I could use some shenanigans to make this point free, but, like, what's the point? And now that means validate function field access expression. This one becomes the exact same thing, except we validate a function expression there. And here it's the regular expression constructor, not the L value constructor. And this one indeed, for the L value expression, gives me an L value expression as a result. Okay, so that should be fine, which means I can go back to L value expression here. Nope, that's the wrong one. This one. And validate function field access L value expression. That's already done. So now we should be able to handle L expressions in assignments, which means we can try, when this compiles, of course, we can go back to this example that we're trying with. I'm going to comment out everything else for now. Okay, so here, plus is a function. Oh, that's the symbol. That's the compiled. That's the ready to be compiled version. That's the validated version. I'm only interested in the definitions for now. Plus is a function that has no type parameter. It's not a generic function. It takes an argument x of type int type, an argument y of type int type, and returns an int. Likewise for minus. The implementation of test function pointers is the interesting stuff. That's very hard to read. So let's copy it in a different buffer and have a look at it. So the function body starts here. There we go. Aha, then that's the if body there. So I'm going to indent that one. Okay, that's not going very well. That's fine. Where is the end of this if body? It's there. Okay, and the if else is nothing. That should be good enough to read what's happening. So, because our function here does let f equals minus, if add, which is a boolean, f equals plus, and then returns f of x and y. So this is function pointers. We don't have an ability to represent function pointers with like type annotations in this language. So this is kind of ad hoc, but this should still work. We can't test the code yet, but at least in terms of compilation, this did return something. So the first instruction is a let statement where we are putting something to a value, to a name f. Its type is a function type such that the arguments are part of the function type. I guess for function pointers, that's... Would that be a problem, actually? I'll have to check. by value int type, by value int type is the important bit and returns an int type. And the value is a function name expression where the name points to the minus function. Then what do we have? We have an if statement where the value of the condition is a local variable expression where we're looking at the variable add, which is of type boolean. There we go, type info bool type. And the body of this is this with location. It's an expression statement, but since its type is unit type, it doesn't give us a warning. And it's an assignment expression of something that on the left hand side is a function type. And that is a L value expression, so an L expression, which is the identifier f. And we are assigning a function name expression there again, pointing to plus. And then at the end, we have a return statement that contains an expression of type int, which is the result of doing a variable call expression where we call the function pointed to by f. The function type info here has the int type for the arguments and the return, which is how we know what to give the thing. And we give it two arguments. One that is an int that happens to be a local variable expression, which is x, and the second, which is an int, which happens to be a local variable expression that is y. Okay, that looks good. Let's just check that the type checking on the function pointers doesn't use, like if I name this a and b, this should still succeed. And it does not. Error role not found. Interesting. Oh yeah, of course. That of course it doesn't compile. I'm saying those are called a and b, and I'm doing x minus y. That makes sense. Okay, now this compiles. So the function type that I carry around for the type expression still has the name of the arguments, but they are not used for type checking, which is fine. Okay, so that works. I'm pleasantly surprised, but well, that works. We don't have like lowering into AR and compiling into an assembly or a Piètre program yet, but at least as far as the type checking goes, this seems to be working. That's pretty good. I'm happy with that. The other thing I'd like to test, I'm gonna do more tests of things. Or actually, before I do that, let's test something when the types are wrong. Like minus is actually something that operates on characters. That gives me now a bunch of diagnostics. What do I get? A bunch of error wrong type. Line 35. So here f equals plus. That gives me this gigantic diagnostic because we are expecting a function type, and we got another function type that's not compatible. Then what do we have here? Error wrong type character int. Oh, so I get an error. Aha, that's not great. That's a result of me doing a bunch of try everywhere. I have an error for this function type here doesn't match this function type, and the x value, the x type doesn't match the arguments don't match one by one. Like expecting character type got int, expecting the character type got int for all of them. That's a bit on line 37. Oh no, on line 37 on this one. Wait. Yeah, of course, because here minus is the one that expects characters. No, no, this is actually working much better than I thought. This function now expects characters, so this assignment here fails, but here I'm calling it with int, and I get an error for I'm giving a character to an int to a character for x. I am getting an error for giving an int to a character for y, and I'm getting one last error. What is this one? Error wrong type on 929. Oh yeah, this returns. This is a negation operation on two characters. Okay, so no, that's failing the way it should. That's great. Okay. Now, something else I want to test now that we have finished the refactor. Well, finished most of it. I'd like to test. I'd like to test type. What's the word I'm looking for? Type inference for structs and for function calls. So let's try this. Let's imagine I have some struct foo parameterized by two types t and u, and it contains a field x of type t and a field y of type u. Now, if I have a constant c of type int, let's say, that is initialized as, let's create a value of type foo by giving x a character and by giving y a boolean, and then doing a field access and then casting as int. You will note that here I have not given the type arguments to this struct, but it should be fine because the concrete type can be determined by looking at the fields. So this should compile. Okay, it succeeds. The type of C is, it's a constant definition. Its type is an int, and its value is 102. And if I look at the value of this character as an int, that's what I get. So, okay, so this worked. The type of foo could be inferred from the type of the fields. Which means if I were to type this explicitly as placeholders, this should work the exact same, except no. Why did not... Oh, because it's this syntax. And now this works because, again, this syntax, like those patterns match whatever I have given here. However, if I were to put an int here, saying like whatever the first type is for t, u must be an int, this will not work because I will find that the information I have for this type is Boolean here. Or it should fail. That's what I expect. Diagnostic. Incompatible type between int type and Boolean type. Perfect. And if I remove one argument, I only give one, that should be fine, but I should get an error between int type and character type. Perfect. That's perfect. If I give too many, I should also get an error. Error incorrect type parameter count. That's perfect. And lastly, if instead foo has only one type parameter, that takes and both fields are the same. Now here they are incompatible. I should get an incompatible type error again. Oh no, this compiled. Oh no. Oh no. Here I get an error struct incompatible types because I do find indeed that the value for this type is either character or boolean, depending on which field I'm looking at. But if I remove the placeholder here, the error doesn't happen. Oh no. Okay, we have a bug. Let's go fix it. So this would be in a constant expression, a constant struct expression. Thankfully, both for functions and for constants, we are using the same underlying function. We don't duplicate the code, which is nice. So what's happening here? Oh, first, I guess I could try this. Here, if I put a field z that doesn't exist, I should be getting an error. Indeed. I get error struct unknown field, z is not now known, that's fine. Oh, do I still have the error if a field is missing? Error struct missing field, I am missing the field y, perfect. So those errors are still working properly at a glance. So the validated fields are, I've been through the field values and I have validated all of them. Perfect. So now, since I've done the traverse, I have a non-empty list of identifier and validated expression with a type. I make that into a hash map. That makes sense. And I'm using union. So for each name of a field, I will create a list of values that have been given for it, or non-empty list probably actually. Which means that if I have y appearing twice, I should get error struct duplicated field. We do handle that case as well. Okay, so far this seems to be working pretty okay. But we know there's a bug. So let's have a look here. We create the parameter map by doing a validate field, which is this function here. So for each field, we check that if there is no definition for it, that's a missing field. If there's one expression for it, we can do something. And if there's none, then there's more than one error struct duplicated field. So here we build a type parameter map, which is going to be, okay, what are the types of this field? What are the type of the expression? Oh, we are expecting this thing to be a vector of e, and we found vector of int. E must be int then. We build this map from type parameter to actual value. But it is, I think, in this part here that we get the wrong thing. Yes, that's the issue here, I think. Because we are doing this traverse for the validation of the types only on a thing that zips the expected types to the ones that have been given. I never remember which is which between struct types and struct params and struct type params. Let's have a look at validated. So those will be the types, which will be partial, I think. And struct params should just be the names. Yeah, okay. So struct type params are the things that have been given. So what that means is, since here we are zipping with this thing that may not have... Oh, where do we check? Oh, probably in validate struct type. No. Where do we validate the number of type arguments? So we validate a non-empty partial type, we get a struct type, we return the struct info. Because we do check that, right? Like here, if I specify 3 arguments, I will get an error. Yep, error incorrect type parameter count, which is thrown from one of those old... No, it is... Okay, it is an int function in types. Which is validate params. So somewhere in there, not here. Fascinating. So we do it somewhere. But not in this function. Where does it happen then? Oh, probably in retrieve struct. No, because we're only giving the base name. No. Where do we do this validate? We clearly do it. We clearly return an error if the parameter count is incorrect. I don't know where we do it. That's fascinating. Because validate struct type is this thing. Oh, would it be done as part of validate non-empty partial type? Probably that might be what's happening there. That's what's happening. Here in validate non-empty partial type, which is just a wrapper around validate partial type, we look at the thing that was given as an argument, and it must be a type. If it's not a type. If we find a struct, we validate the struct type, and when we validate the struct type in the case of a partial type, then we validate the parameter count. That's where it's done. Okay, mystery solved. However, here, when I want to create this mapping from... That's the mistake. Okay, I see now. Here I'm saying, okay, for each name of a type argument, here's the value that was given. I am under the assumption that I have checked that the number of arguments is correct. However, here, this is not a regular like application of type parameters. placeholders are valid. Therefore, this list might be incomplete. So this one needs to be made into an infinite list by doing which one is it again? I have an A and I want an infinite list of A. Repeat. I want to repeat nothing. Which creates an infinite list, but since we're zipping with a finite one, that should be fine. Okay, so now we see, okay, we have the error incorrect type parameter count, but now we should be basically not putting this should be the same as putting nothing for all of them. And now this should be the diagnostic of, there we go, incompatible types. For the type T of foo, we found both character and boolean. So here, the type inference fails. And if we go back to this, then that will succeed because now the type inference can succeed. Okay. So type inference of struct expressions seems to be working. Now let's try type inference of functions just to make sure that this works as well. So let's do, I suppose I can use this B1 here that I have already as part of this test. Let's do a function foo, no arguments, no return value. Perfectly fine. This will just do a call to B1 with an int, and then B1 with a character. And that should be enough for it to do the type inference there again. So let's try that. Oh, there's another thing I need to try afterwards. Okay. Internal compiler error. Ooh. Function definition not found. Yep, that is the bug I was complaining about. Functions were not added to the interface. Okay, so this bug prevents us from testing this thing. That's fine. The other thing I wanted to test was if I have a type argument that is not used in the fields there, which is very unlikely for a struct, but we still want to test this. Here I should get an error because for the type V, the fields do not provide any information, so we cannot infer the type of this thing. So here I should get a normal error, not an internal compiler error, ambiguous type for the type parameter V. Okay, so this is working as well. So now we should fix the missing definition problem, because here in the function section, we should be expecting the definition of B1 that should be made available for instantiation at a later point, which wasn't the case here. So let's fix that. This will be at the top level in the validation file. When we validate a function, in here in validate function type, here we do, if it's not generic, then create a function instantiation request. That's something we fixed yesterday, and I want to clean some of this. I suppose the other thing we need to do is, if it is generic, it needs to be added to the special repository of generic functions, which is our function cache in our state, which happens to be, if I look at interface, a hash map from base name to the resolved function info. So what we had as an argument, basically. does it need to be added regardless of whether the compilation succeeds or not? I think so. This might be something that is wrong that we might need to fix later, where if the type. Let me just check something. Okay, we do an ensure there, which means we do not try to perform instantiation if any of the definitions did not pass correctly, did not like analyze correctly, which means I don't need to put my function in the cache of generic functions if it did not succeed. I can do it, but it doesn't matter. It's not needed because we will not try to do instantiation and we will therefore not try to do lookup in that cache if if anything goes wrong before that. Okay. So I can do it at the end. When I validate a function type, here I can replace this with if is generic info, then do something, add it to the cache, else this thing where we register it for instantiation. And here, this will just be modifying the cache, which is our function cache, which is the VS functions for validate state. And we use this lens to point to that cache in our state, and we apply a modification function with this operator. And the function that we apply on it to modify it is an insert. And that's probably just going to be base name and the info, I think. So now, let's comment this out. I should be able to see after this, if it compiles, of course. And base name is not in scope. Where do I get the base name? I'm gonna need the base name anyway. Let's retrieve it from here. Base name is use current name. There we go. Ah, this needs the location. Interesting. And I don't have the location as an argument. That's interesting. Well, I have it here with the def location, so I can just rewrap this as being a with location, def location of the info. Because I think I do the same thing here. Oh yeah, I do exactly that, which means I could probably just do original definition here. And that's going to be a with location, the def location of the info. Before we try to do anything else. Okay? That means here I can remove this base name. Or I can put it here, actually. I think this looks better when it's zoomed. Yeah, it looks okay when it's zoomed out. I'm gonna keep it that way. Okay, and that just means here this definition is the original definition. And the thing I'm inserting here is the original definition as well. Okay, I'll zoom this back in because it's going to be easier to read on stream, I think. Okay, that compiles. Let's go back here. Okay, so now in the definitions, I see this, which is just the function type for B1, which is a concrete validated version of the function type. But in the functions, I see the raw resolved version that can be instantiated at a later time. And there is no symbol in the output of this module because there is no concrete function. Now, if I uncomment this, if everything works, I should see a symbol for foo in the symbols of this module, and I should see a symbol for b1 of int and b1 of character because we will have instantiated that function b1 twice. And we get an internal compiler error instead. No information for type parameter. Okay. So that happened in refi type. I wonder if I can. That's something I should have looked up. Is there a way for me to just. No, no AI mode. Thank you. Is there a way to put has cold stack everywhere? I don't think I want to, but. Um, would it work to make. Would it work to make everything that has monad diagnosis require has cold stack? I don't think this makes sense. I think this will be rejected by the compiler. Well, because it's not import ghc.stack. Yeah, that's an implicit parameter. That's not something that makes sense on a class constraint. That makes sense. Okay. So what's happening? What's the bug? I am trying to reify a type at some point, and I have a type parameter b1 t of b1. I end up in a situation where I'm like, what is the value of this? And I don't have a type for it. There is one place where I suspect the bug might be, but I thought I had fixed this already. Let's see. Instantiation, that's here. So when I instantiate a function, I do set the parameters to a hash map that zips the parameters with the one that we have given as part of the instantiation. I guess this could be empty. Excuse me. Excuse me. So we could try to debug this, make sure that this list is correct in the first place. And if it's not, it just means that when we try to do some reification, we might not be using it properly. Okay. So first, let's import our good old friend debug.trace. And here, let's do a trace m of begin debug. then trace show m of I want to check what the name of the parameters are, and I want to check what I believe the values to be in this context. If that is t and int and t and character, then that should be fine. We should be creating the correct mapping underneath. So let's try that. I get an empty list and an empty list. That is very wrong. Oh, wait. It depends on what I'm instantiating first. What is the function I am currently trying to instantiate? It is foo. So that makes sense because foo doesn't have any arguments. So it makes sense for it to not have anything here. Okay. But that means that the error we get is during the instantiation of foo. Okay. So in something in this part of the code is broken. I see a substitute types function in this module. I suspect this might be where things go wrong. Oh, this is the old version of the code. I'm looking at the wrong file. Okay, so I instantiate a function. So I look at the block. Perfect. I look at the statement. Here, the one that will cause something to instantiate the function will be an expression statement. So let's have a look at validate expression statement. We validate a function expression. Okay. We no longer have purity information. That comment can go away. Which means we have to go look at expression. And I guess validate function call expression is what we want. The role points to an actual function name, b1 in this case, so this would be validate function call function name, a very, very verbose name for this, but it's this helper here. So here we retrieve the function type. We validate the parameter count, which should be less than. Aha, we have the same problem again, where here, since we accept a number of arguments that is less than, the named partial params here will have to be zip with this plus repeat nothing. Because otherwise, if we don't do that, then when I try to iterate on the named partial params, I'm not going to get anything. Okay, this could be the bug. Okay, so now we instantiate foo correctly, and then we try to instantiate b1, but we don't have type parameters there. So since we don't have type parameters, we cannot create a hash map from, and I suppose then the internal compiler error is parameter name not found. We don't find a value for t. Yeah, okay. That's annoying. I suspect that at some point I've made the choice of removing the name of the type parameters from the instantiation request, and I think that's wrong. Because here in validation, it makes sense for the request to not have parameters because this is not a generic function. I don't need to check that. However, I think here in expression, when I find function call, this one here with the function name, oh, actually, do I register the function for instantiation if I find a function name in an expression for a variable for a function pointer? Let's check that quickly. In the case of a function, a validate function path, this one, I do make a function instantiation request. Perfect. And here I am giving the validated parameters. Wait. The fun params, where do you come from? Ah, from the function type. Okay. So here the function type, that's the validated function info, and here it doesn't contain the type parameters. I have made the choice to say, well, the request at this point, the function is concrete, therefore it doesn't need the type parameters. That's wrong, it still needs them. So this will be the fun params. And I think it's going to be the same thing for a call expression down the line, somewhere around here. There we go. Register function for instantiation. Here, the fun params must be preserved. And if we preserve them, I want to believe, now this compiles, which is good. No longer any internal compiler error. We did get that when trying to instantiate b1 for t, there was an int, and then we tried to instantiate b1 with t as a character. Perfect. I can go back here. I can remove the import of debug trace. I can remove my trace here. And the result, what does our function look like again? b1 is just returning a value of the same type. But if I look at the symbols of our module, so that the actual functions that would be linked against that are part of the symbols, we do have an entry for main b1 of built-in character, which is the unique name, which is the mangled symbol name for this particular function that we can link against. And it is defined. It is a function info, has a type info, which it takes a type parameter t. That information is preserved, and it has one argument x of value character, which is consistent with it being a character here. It returns a value of type character, and its body is only one statement, a return statement, where the expression within is of type character, and it's a local variable expression where we return the value of the variable x. And it's the same for b1 of int, except the identifier is of type int, the return value is of type int, and we are returning a return statement of a local variable expression x. So we are instantiating functions correctly after fixing this. So not only have we fixed the fact that generic functions must be exported with the definition so that they can be instantiated later, instantiation of generic functions seems to be working. Something else I can try. Let me just check this quickly. Okay. The other thing we can try is, do we register functions for instantiation correctly if we create function pointers? For instance, here, if I do f equals b1, this should fail. I am not familiar with pi calculus at all. What is it? Well, beyond what you're saying of the concurrent brother of lambda calculus, I don't think I've even heard the term before. Okay, so here this should fail because we are trying to call b1, but b1 is a generic function, and with this we don't have the context to be able to figure out what the type of it is. So this should be not an internal compiler error, but a regular compiler error. Error incorrect type parameter count. That seems good to me. And here, those should be concrete types. So giving b1 only one argument here that is a placeholder should also be incorrect. Except this is not the syntax. This is the syntax. Error, not a type. That's a placeholder. That's not a type. Okay. So now if I do this, I am saying b1 of int. That's a path to a function, creating f as a variable that points to a function that's valid. So this function should compile, and it does force the instantiation of b1 of int. Perfect. Okay, that looks good. What else do we need to try? I think before I move on to actually making actual changes to the code and start like fixing the things we need for tests, I want to try to investigate why the cyclic definition thing results in too many error messages. Because here, if I have 0, for instance, this compiles just fine. A is 2, B is 1, C is 0, that's all good. But if I remove this, this should be an error because A forces the evaluation of B, B forces the evaluation of C, C forces the evaluation of A, and that's a cycle. So that should result in an error. But the problem we have is it results in 3. So let's have a look at how the cycle detection works, and let's try to figure out why we get 3 errors instead of 1 here. When we do the validation of something, like a constant, for instance, we start by looking at whether it has already been validated. If it already has, then we just do a lookup of the definition. That's fine. Otherwise, we check whether it's part of the current stack of things we're stacking on top of one another. And if it is, error, cycle definition. And otherwise, if it's not a cycle, so I don't know in which order we're going to try to do A, B, and C, probably in the order of declaration, so probably A first. So we try to do set up the validation, which is put A in the stack. And after validating A, if it succeeds, we remove it from the stack and we label it as validated. Well, no, this teardown happens even if validating A fails. That's a finally. That's the whole point. So we should always mark A as validated, even if we encountered an error in the process. I wonder if it's because we have a try here that we have a problem. Okay, so we are trying to validate A. We start performing the validation, and we find a reference to B. So we stack this, we stack a context on top, and we start looking has B been validated already? No, so we have to do this. It's not in the stack, so we put B in the stack and we start validating it. While doing the validation, we find C. We find C, so we call this recursively. It hasn't been validated yet. It's not in the stack. Put C in the stack, start validating it. We find a definition of A. We go here. It has not been already validated because that's done after in a teardown. But it is in the stack, and so we throw an error. Since we have thrown an error, actually, let me check something. Yeah, I do have one for A, one for B, one for C. So all three of them give me an error. Huh. That's weird. Oh, that's interesting. Yeah, I was not familiar with that at all. There are some languages that do like model everything as this kind of like agent in this sense, not in the shitty AI one, where everything is basically. Does Go do that? Interesting. I had Smalltalk and Pony in mind. But I guess Go does have like yeah, pretty like language level support for channels and everything. But wait, so we were in C, we stack a definition of A that gives us an error cyclic definition. So finding the definition of A fails, so the validation of C fails. Okay. So here we should. So I don't understand. I don't understand where those other errors come from. Because on the way back down the stack, we should be putting them invalidated, and therefore we should not attempt to validate them again. Let's do some debugging. Let's invite my good old friend debug.trace there again. And let's figure out what happens. So, here let's do a trace m of so this is going to be set up for whatever the current name it yeah, this thing of the base name. And I'll want also to get the current stack. So it's going to be use vs definition stack. There we go. So let's see what the stack is like when we start doing this thing. here the teardown, let's try it. See, we're gonna be doing tear down of the base name, and we can show the stack again. And validated should is a set, and it should contain our base name as well. Okay. And I guess here I could show what has been labeled validated so far. And the last thing I want to do some kind of debugging is here. When I have to throw an error there, I will want to do a trace M of, should I copy this? No, I have nothing of the sort at all. This is a much simpler language than, like, we don't even have a heap in this language. There's nothing dynamic about it at all. It's purely stack based. So that kind of complexity is not part of the language that we're trying to do. As an extension, it could be fun, but you know, not in the first pass. So I want to detect here is a cycle. Oh. No, yeah, I want the base name. I want to see, oh, this is the place where I found the error. I want to have a look at the stack. Which is just a def stack that is in scope. Oh, sorry. No, I'm not doing anything like this in the compiler itself for now. I will maybe consider it when I am doing, because at some point I'll have to put everything I've been doing together and do incremental compilation. And there's absolutely no reason for me to not parallelize. Like, if I do the graph of my dependencies and I realize there's a bunch of leaves that are not connected to one another, there's absolutely no reason for me not to parallelize them. I don't think if I parallelize them, I'm going to do this with agents. I don't think that would be the right approach in Haskell. But I will definitely, I think, want to do some kind of parallelism and things like this when doing incremental compilation. But we're not there yet. But yeah, I think I will want to do that. There's no reason to do, like, basically, if I can make the graph of dependencies that need to be compiled, anytime I have things that don't depend on anything else, I should be able to just spawn them and then wait for them to be done. Yeah. So maybe I'll do something like this. I'll see how I want to implement it. I haven't actually thought about it yet. There's something else I want to check here, I think. Yeah, I want to also check that this piece of code is correct. So let's do this. That's a bunch of trace. Let's see what happens. Okay. Let's go here. Let's go here. And let's go here. So. Oh, that's B1. I don't care about B1. Setup for A. That makes sense. So I'm trying to analyze, validate A. The stack for, oops. the stack for now only contains A. That makes sense. Then we try to validate B because we found it while trying to validate A. Oh, we are putting B at the beginning of the stack. I suppose that makes sense. Does it? I think it's not what my code expects. Maybe that's why the list is wrong. Oh yeah, I'm putting it at the beginning. Which makes sense because it makes a teardown just being a drop one, I think. Ah, it's a delete. Can I do that? Except, yes, it's gonna be here, I suppose. Okay. So, we try to set up A. We put A in the stack. We find B. We try to set up B. We put B in the stack on top of A. We try to set up C. Our stack contains A, B, and C. We try to find A again because C depends on A. That's a cycle. And our stack contains A, B, C still. And our list will be A, B, C. This time it's correct. Yes, I'm cutting everything until the cycle. So if we had D, if you had A that depends on B, that depends on C, that depends on B, here we only have the B and C, we would drop the A. Yeah, I think that's correct now. Okay, so we tear down for C, where the stack is A and B. So we label it as validated. And we have removed C from the stack. Wait, why do we have B1 and C there? What's happening there? What am I printing in the teardown? Oh, I'm printing stack and then validated. Okay. So when I found the cycle, I do a teardown. The stack only contains A and B, but then it contains, in the validated stuff, B1 and C are both considered validated. I try to tear down B because I'm on the way back down the stack because we found an error. After which, the stack only contains A, but the things that have been validated contains B1 and contains B. Wait. Where is C? Where is C? Because I do a validated insert the base name. And on the way down, so when I show the validated, oops, when I'm tearing down, oh wait, I'm tearing down C? I'm not tearing down B. Wait, what's happening there? Why am I doing a teardown of B and then A and then C? What's happening there? Why am I not going through them in the stack order? Like here, my teardown is B, but my stack contains C and A. What on earth is happening? Oh, wait. I'm looking too far down. Okay, that makes more sense. So I am starting with a teardown of C. That makes sense. And the list of things that have been validated contains B1 and contains C. But then I'm doing a teardown of B on the way back down. My stack only contains A now. But for some reason, oh, this is cursed. But for some reason, I'm an idiot. Of course. That's a problem I have seen coming for a month, and I thought I'd be fine, and I wasn't. Ah, of course. Okay, this is gonna be tricky. I don't know how to fix this. It's fixable. I just don't know how to fix it now. Here's the problem. My state monad, this one right there, that contains a bunch of stuff, such as the definitions that we have validated, the functions that we have encountered, the function instantiation request for the thing that we need to instantiate later on, the context in which we are operating, all of this is in a state monad. That state monad is on top of our diagnosis monad. So our stack of monad is state on top of diagnosis on top of whatever else is underneath, probably IO at the bottom or something else. The problem is the diagnostic monad can short circuit. If it short circuits, if I do a try in a monad above, when it short circuits, I lose the context, which means that when I do, where's the try? When I do a try here, if something happened as part of this, the changes I've made to the state, are lost. Meaning that when here I set the validated thing, that is not persisted, because if an error happened as part of this, there maybe the trivial way to fix it is, since I always do a try at the definition level, so we never short circuit more than that, then maybe I need to not do the insertion of the validated thing as part of the teardown. I need to do it afterwards, after the try, basically. Yeah, I think that's the only correct way to do this. To the point where I'm starting to wonder if, for this specific case, the bracket thing is actually correct. Well, correct. It's not wrong, but since if there is an error, whatever I do in the teardown that is maintaining the state is gonna be lost anyway. Maybe here I want to not do the bracket. I want to be more explicit about this. Therefore, I think for this one, I'm gonna get rid of the bracket. So instead of doing this, setup, teardown, and everything, I'm gonna copy this back. I'm setting the definition. That's our setup. Just I need to label it. Then I try this thing. And I guess I can put it in the definitions after the try. No, I guess I can. Okay, perform validation might stay. That way I can do result is try perform validation. And then afterwards, so setup goes away. And teardown goes away as well. And here I do the changes to the state after the try, which guarantees that the changes to the state are persisted even in the case of an error. Which means this needs to happen here. I remove the stuff from the stack. I set the thing invalidated, and I finally return the result, and this can go away. And now that should... I should also be able to remove debug.trace. There we go. Yes, I don't need the cycle anymore. And I will not need control on that catch anymore. And now I should only get... I only get one diagnostic. I only get one diagnostic for a cyclic definition. I only get one, because then, since I'm putting the validated afterwards, after the try, it is persisted. Therefore, if I have detected a cycle while looking at A, B, and C, I'm not going to try to validate B again and then find a second cycle, and C again and find a third cycle. So I only have one error as a result, which is this one error cyclic definition. And the cycle is A into, like, A into B into C back into A, basically. And I can check that the truncating of the stack works correctly by checking if instead C depends back on B, I'll still be trying to find the cycle in A. Because A is the one I'm going to process first. But I should, despite the fact that the stack will contain A, B, and C, I should only have B and C in my error message, because I'm going to be truncating to where the cycle is. Aha, I have more than one diagnostic now. What's happening now? So I do have two cyclic definitions. Because B has a cyclic definition, okay, where the stack is B and C. But what else has a cyclic definition? Huh. How do I report it twice there? I think it's the same problem. I think it's a similar problem of my state is not persisted because of a try. And since it's not persisted because of a try, I lose the fact that... that's annoying. Yeah, that's what's happening. So it's less worse now, but we still have... Yeah, when I'm stacking definitions on top of one another. Oh god, that is a significant problem. Because that means that if I am doing the definition, if I'm trying to analyze a definition A and then I stack the analysis of a definition B, but then the definition A fails, I catch the fact that A failed, but I lose the changes that I've made by doing the analysis of B, which means we're gonna redo the analysis of B. That's not the end of the world. We're not gonna have something that's wrong. We're just gonna redo some work that's not required. Okay, I'll have to think about a way to maybe persist things despite the short circuiting. If I had a proper effect system rather than stacking monads, then I wouldn't have that problem, I suppose. But I probably don't want to do a big refactor to then add an effect system to this mess. Yeah, that's the problem of having the diagnosis monad at the root, is whenever I'm doing a catch, I am losing all of the changes that have been made across. Yeah. Frustrating. An effect system is a more generic version of this, where like you operate in a monad. I have never actually used one, so I'm not the most qualified person to talk about it. But instead of like here, what I'm emulating one by stacking monads. I am in a bunch of monads that each perform like offer some kind of functionality. Like my validation monad um, provides access, a reader access to those things. It provides some state with this stuff. On top of this, I happen to have a monad that provides diagnostic capabilities, which means stocking errors, stocking warnings, and being able to short circuit. But this is implemented as being stacking monads on top of one another. There are other approaches to achieve this thing of like, I want to be in a context that provides those features, where you delegate to an effect system, and the effect system you register saying, I need this to provide me with those capabilities. And it's, of course, implemented with monads under the hood, but you can use implementations that are not stack of monads, but more generic, that delegate to a system of like type maps to where, like, what to find the correct effect for a given thing. I'm not explaining this well because I've not implemented one myself, so I just know what they can achieve. I don't know how they are implemented, if that makes sense. So if I were to use an effect system rather than using a stack of monads, rather than having a thing on top of a thing on top of a thing on top of a thing, where the order in which they are stacked matter, I would be saying, I operate in a monad that has the following effects, is able to short circuit, maintain some state, and so on. And hopefully, with a correct implementation, I'd be able to do that without having to care about this kind of like loss. Oh, it's still on the Hazara repo. I had forgotten. Ah, that's because she stopped working on it, I think. Yeah. Yeah, well, you can register effects that then inform how the monads like provides things. Like the example here in this repo, which hasn't been maintained sadly, this was one of the most promising implementations. I have not checked other implementations of effect systems in Haskell. This one was very, very like, because Alexis was doing a lot of work on making it extremely efficient as well, which was pretty nice. Like, yeah, let's provide an effect, which is a file system, which provides read file, write file. So this is a capability of the thing, which I could implement in a monad stack by saying, well, I happen to be on top of a monad that contains IO and provides those services, basically. And then with this, you can do read file, write file, that given that we are in a monad F that has an effect that happens to be file system, then we can send to F the command read file and it performs the thing. And here I could be doing something of like, oh, I happen to be in a case where I have IO as part of my effects and I have a file system there and I can do those things. Or I have a thing where I have a file system as part of my effects but not IO. Like I could delegate to, I can run functions that say I am in the context where I have this effect in scope, basically. I don't remember, however, how this is implemented because, again, I have never actually used an effect system. Okay, so I'll have to think about how to get... How can I persist things despite the fact that when I stack effects, effects. When I stack monads, I lose... Let me show you an example of what I mean because that might be better. If I do a stack GHCI, I have everything. I've done this before, but I don't have it in my history, I think. Okay. If I import control monad state and I import except, one thing I can do, which is very similar to the way things are done with an effect system, is I can write a function. Who is a function that expects that we are in a monad that provides some kind of error capabilities where our error message is a string. So our monad M has the effect monad error with a string. We also want to be in a monad that provides some state, where our state is some int. Now, if we are in such a monad, regardless of what monad it is, then foo can be a function that... What will foo do? Let's say that foo is gonna just return... It's gonna just be an action in our monad that doesn't return anything. And the implementation of foo will be... Let's get the value of the state, which we can do because we know we are in a monad that has some state, has a state effect capability. And we are gonna say when s equals 0, then throw error 0 in the state, which we can do because we know that this monad has error capabilities. And then at the end of this, we are going to put something in the state. What are we going to put there? Let's say s minus 1. There we go. That's a function foo. That's a valid function foo. That, as long as we execute it in the context where the monad has error capabilities with strings and state capabilities of int, it will just, like, it's compatible regardless. Now the question is, in which order, like, what is the actual monad in which we run this? If we run this in state on top of except, the result will not be the same thing as if we run it in except on top of state. So if I run my action foo that gives me something in some kind of monad that has the combination of both. And let's say I have except on top at first. So I will run except t to remove the stack of except. So now I have something in a underlying monad, and I will run the state to get then the underlying base thing, which in this case is going to be IO. So flip run state, and let's say that my starting state is 10. Ambiguous run state t. Let's import control monad state as S. So the type of this is this gives me a tuple of the result of my computation, which is right, it succeeded, and the value is just unit because foo returns unit, and my current state, which is 9, because when I run state, it gives me a tuple of my computation and the value. Now, what happens if I put 0 here? Well, my computation failed because there was 0 in the state, which we did not allow. But that doesn't work either. I'm gonna have to change something for this example to make sense. I'm gonna have to change something. I'm gonna have to rewrite foo as being almost the same, but instead I'm gonna say that I'm modifying the state first before doing the when that throws. Okay. So now if I do this, I run except t, transform something that is an except t of m and the except t, the error type, in our case string, some kind of underlying monad, and a value a, it turns it into, in the underlying monad, either string or a, and then we do a run state that converts, which converts this thing, which happens to be therefore a state t of int on top of m, the underlying monad, and transforms that back. Given that I give it the argument 0, it gives me at the end a tuple of, in the underlying monad, either string a and the int. So that's what's happening when I do things in this order. But if I do it the other way around, when I flip the run state t first, then I so here I am running except first, but if I flip this, I run the state first, and then I run except t. Here, I don't get the state. I only get the left with the error message. And that's because if we look at the thing here, well, I start with state t on top, and that's the first thing I remove. So I remove this state t by providing the zeros as starting argument. So what I end up having is, in the underlying monad, which happens to be except t of string, I get my tuple, which is my a and int. A is the result of the computation, int is the state, and then I run except, which means in the underlying monad, I get an M of either a int, well, either string or a int. Meaning in this case, and on the way down, the state is bundled as part of the either, while here, since the exit was on top, the state is not. So when I do shenanigans with try, if the state is above and I remove it first, any modifications that happens after a throw is lost, basically. And I cannot prove that they are interchangeable because, in fact, they are not. Different monad stacks result in different types. One of them gives me a IO either string of unit and int. The other gives me a IO either string or tuple a int. So it gives me different types based on in which order I've stacked the things. And here, what I've done in all of this code is to stack my state on top of the diagnostic monad, which is fine as long as I don't need to process state across. And it would be fine. Like it is overall mostly fine because when I do validation here, validate definition, I always catch with a try the perform validation, and I change my state afterwards. So, okay, if something was performed in this validation, it's lost, but most of the stuff is not persisted as part of this anyway, so that's fine. So because it's done here afterwards, we catch it, we move to the next definition, it's all good. I am not sure how an effect handler would handle that case, because again, I haven't used any of those libraries. I know that they are like, this is a known issue of like the stacking order makes a difference. I think that if I remember correctly, a lot of effect systems do have a thing in place to deal with this, but I do not remember what it is. I guess something I could do, actually. Because this would be fine. The only reason why this isn't fine is sometimes when I encounter a definition, so when I do this perform validation there that is in the try, I recursively go to another definition. And if then that one fails, I pop all the way back here, and the changes I've made to the state around those things based on the definition I've been looking at are lost. Something I could think about, something I could do is those functions operate the way I have written most of those functions is to say, I am in the monad that has the diagnosis capability, and it is in validate on top of that monad that has the diagnosis capability. Something I could do if I really want to fix this, I don't need to fix it this evening, so I might not, would be to instead say, I happen to be in a monad that has the diagnosis capability, and it has the validate capability, and my code returns something in that monad. And then the caller can decide actually the diagnosis thing is on top, therefore any change made to the state underneath is kept in case of a short circuit, which is probably what I will want to do at some point. I think that is the right approach. And that just means that whenever I run, but no, that's a bit annoying. That's a bit annoying. Because having the validate capability is not... Because the way I've structured this thing is every phase just run its own monad with its own capabilities on top of a shared monad that everyone has access to, which happens to have the diagnosis capability. So I don't think this approach would actually work. So I need to think of a way. I have two options. Either I find a way to cheat and to persist some of the validation, even in the case of a short circuit, which I could perhaps do because, like, there might be a way, since the way, like, this particular validate monad in which I'm operating. Monad, where are you? I decide what fatal the thing that short circuit does. It's calling report error, which is part of the monad dialysis, which is underneath it in the stack. But maybe here I could decide actually when I do that, this thing, maybe there's like some kind of, there is another capability underneath. Like maybe monad diagnosis has like some buffer space or something like this that can be used for storage of things that can be recovered. I don't know. I could try to find something smart there. The thing is, if I don't, it's not the end of the world. The only thing that it means is I might try to do the analysis of a thing more than once. That's the only consequence at the moment, which is not the end of the world. Which means I think for this evening, I'm gonna leave it at that, and I'll have to think of something better later on. Is there a way I could? No, I'm explicitly stacking definitions. Okay, no, I'll have to figure something else. This will not work in the current state. But again, at the moment, the only downside of this approach is I might try to validate the same thing twice. But it will not result in differences. It will not result in the wrong state being emitted. It will just result in the same function being like passed, like evaluated twice. And potentially, if things go wrong, more than one diagnostic for the same error being emitted. But it will not result in the wrong code being emitted. So I think I'm okay with this for now. I think I'm okay with this for now. Although it's not great. I want to think about it, but no, I'll think about it off stream to see if there's a solution I can use for this. Maybe it will come down to, because try is currently implemented for all things that have monad trans control. Where I lose the scope. Let me have a quick look at monad base control actually. Because I know that. Okay, so no, it is just monad trans control on top of a monad base, which is not gonna make a difference, I think. Because it is the same problem of I have a maybe A. Hmm. Oh, control might be actually pretty useful. Except now I do a traverse. Yeah, okay. There is also there is also another solution that I don't want to do, but that there is a possibility, which is that our state carries not the actual set, but an IORF. I keep an actual pointer in my thing, and that means I will have to always be operating on top of IO. I will not be able to operate in pure memory, or I do it in ST. Oh, that could be a solution. That could be a solution. I could be operating in ST, the monad that allows me to keep pointers to some thread local data. And instead of having some a set in my state, the only thing that needs to persist across errors, I put a pointer of it in my reader, and when I want to change it, I like dereference the pointer basically. I do mutability. If I do that, the pointer doesn't change whenever a short circuit happens, so the pointer is the same. That would work. That would be ugly, is the thing. That would be ugly. But it would work, I think. I'm tempted to try it just to see how ugly that becomes. Let me check that this compiles still. It compiles but fails. Let's try this for size. Let's try that. Out of curiosity. So my problem is this validated thing needs to survive if a definition has failed. Even if it's within another definition. To do that, I will need to have the phantom type for the thread local state, which will be real world if I happen to be in IO. But in memory will just be that. And in my validate info, I will have a pointer, stref of s, and this will be a hash set of base name. Which means which means I need to have a quick look at ST. There's something, I think it's a pre-monad constraint. stref control monad ST. Not state. Control ST. I don't remember. There we go. It is control monad ST. Where is... I don't remember where it is. I need a prim monad. There we go. Oh, that's the vector one. That's not the correct one. I want this one. So that's the prim state. Okay. So I need to be in the context where I am in a primitive monad that is able to perform some stuff, which includes ST and IO. So that means that if I have validate T on top of M, the parameter to validate info is the prim state of M. There we go. So that's the S that we need here for the stref. And when I run validate T, I'm not going to be able to take I'm going to need to lift something, but I don't know how much to lift prim. There we go. Perfect. So that means I'm going to here take all of the arguments to validate info instead of creating a validate info, which means I'm going to need the definition cache, I'm going to need the function cache, I'm going to need the symbol cache, I'm going to need the local definitions, which is this. Oh, I should have committed my changes before doing all of this. That's fine. And here, so I'll have not the info, I'll have the definitions, the functions, the symbols. I'm gonna do this the quick and ugly way because I don't think I want to keep this code. I just want to try it. The local definitions. And then the action. And here, I'll do all of that the same. But here, first, I'll have to lift prim something which is going to be new stref, where the value is going to be the empty set, so that I can create the info, which is going to be a validate info of the defs, the funcs, the symbols, the local stuff, and our set pointer. Which means here I'm going to need a monad prim constraint, I think. I'm going to need a monad prim constraint in a lot of cases, actually. That's going to be a bit annoying. That's fine. That's fine. And that means the only change, because the only place where we use validated is this one. Instead of doing a use validated, I'll get the set pointer by doing a view validated. And then I will get the validated set by doing a, is it read stref? It is read stref of the set pointer. And then I can do if member the base name of the validated set, and that remains then the same. So this is going to require monad prim of M. And here, instead of setting the thing to be validated, I will do write stref, and that's the set pointer I'm writing to, and I will write a new value, which is set insert of the base name. Nope, that's not true. I'm going to modify stref. I don't want to override with this version. I need to modify the previous one. I modify the thing pointed by this pointer by doing an insert of the base name. Okay. Hopefully that means I only need to put the monad prim constraint. Nope, because since recursion can happen, I'm gonna need to put a monad prim constraint everywhere. That's fine. Okay, so I'm gonna need control monad st, and I'm gonna need data stref. Huh. Where does prim state come from? Is it only really coming from... No, that can't be right. It can't just be coming from vector. That feels... No, it's coming from here as well. Okay, so I will need primitive. Okay. I will need it here as well. Let's import control monad primitive. Prim state is not found. But I did import control monad primitive. Ah, there we go. Oh yes, of course, this S doesn't belong here. Oh, it's prim monad, not monad prim. Okay, control monad st is redundant. So it's prim monad, not monad prim. I'm surprised that the recursive case has not required... So this requires, again, import control monad primitive. That's prim monad. So here validate info is no longer correct. Here I do a run validate t where I give it the definition cache, the function cache, and the symbol cache, and the local definitions. That goes away. It is VI validated, not VS validated. I need to import data stref in scope. Ah, yes, here I will need to lift prim this. And here I'm gonna need to lift prim as well. Okay, and now that means here in validation boot, I need to change this to also be prim monad, which I will need to import control monad primitive in scope for it to be in scope. And now here attempt to validate is gonna require it as well, which means I need to import, oops, I need to import control monad primitive in here as well. This requires it as well as a result, which means this requires it as well. Yeah, as suspected, I'm gonna have to put primmonad absolutely everywhere. I could, for the sake of this test, only put it like make monad diagnosis actually require it, but that feels ugly. This will also need import control monad primitive. Okay. Still in this file. Okay, we've moved on to exp. I should really have committed before this so I could revert it easily. Oh well. The thing is, after all, I could keep this if it's working. What's a bit of mutability in my pure Haskell code after all? Okay. A few more. Could have done just a big replace of all of them with the constraint. That might have been easier. Especially in a file as big as this. I'm down to instantiation, which is nice. Okay, let's just do a big replace of monad diagnosis M by this on all of them, and import control monad primitive. Okay, is that enough? Or did I mess up? I did. I messed up. There you go. Could not deduce prim monad here. Could not deduce prim monad. That's at the top level. Okay. Now, top level here. We need that as well. Okay. That's because diagnosis needs to also be aware of that, and I need to control monad primitive. Here in the definition of the diagnostic monad, I need to say if the monad underneath is a prim monad, then this one is also a prim monad. So deriving prim monad. And now that should be good. Well, again, I'm not sure I want to keep this, but what I'm sure of is it will fix my problem. And indeed, now we have only one cyclic definition. We only have the one. Wait, we have two? No, we have only one. Diagnostic here. That's the error cyclic definition. While trying to define B, our stack contains B and C. Despite the fact that we started doing A, we found B, we found C, we found the error, we labeled things as done because instead of modifying a state that is being lost when we short circuit, I am using a pointer instead. And since I'm using an ST ref, I could run this code entirely in memory without using IO, using the ST monad, and it would still work. So that's ugly. I don't know if I want to keep this. Because again, the thing that makes me want to keep it is I am only using this pointer here. I get the pointer, I read the reference to get the actual set to do my thing, and here after performing the validation, I go modify the pointer again, which hasn't changed. It doesn't change. The pointer is unique throughout the entire computation to go modify the set that is being pointed by this pointer. This is honestly not the worst thing I've ever done. This is honestly not the worst thing I've ever done. I'm kind of inclined to keep it. Like, it fixes my problem. If I keep it, what kind of cleanup do I want to do there? I could consider introducing an alias so that I don't list this needs to be a prim monad and a monad diagnosis everywhere. I could perhaps introduce an alias such as monad validate, which would be an alias for the things I require, for the constraint I require. Yeah, I might do that. I will also keep. This is the thing for which when I do a stream focused on documentation and not on making progress, this will require a note, a full-on note. Because everything here in the state is basically the output of. It is useful as a state, but it is mostly the output of the process. So it is fine. Like, those things are updated if the thing succeeded. So what happens if. Huh. Yeah, okay. The thing that makes me want to not keep this is I would kind of want to be able to do that for everything and not just the validated stuff. In fact, I think doing it only for the validated stuff is broken. Because what happens if I try to define A and then B has a bug, which means I cannot define. Wait, no. I try to define A that depends on B. B succeeds, but A has an error. I get out of this. The state has been lost. So the fact that the thing that succeeded has been defined has been lost, but I have labeled it as validated in my pointer that's not associated with the state. This fixes the problem for validated, but it introduces a bunch of other problems. So I think I don't want to do that. I suppose I could cheat and remove this entire state and only keep a reference to what is actually the state, but that's kind of even worse. So I think I'm giving up on this for this evening. I'm going to revert those changes and I'll think about it off stream to have something better moving forward. Because again, without all of this ST nonsense, the worst case scenario is we perform some checks more than once, which and we report some errors more than once. Really not the end of the world. I can't write a generic monad stack inverter. There's no generic way to do this because, again, the types might not align. The result of a computation in except on top of state is not the same type as the result of a computation in state on top of except. So there's no way to generically flip them, which is also a problem with. Although that one has some solutions, but if you make a new reader, like you make a new kind of transformer like the reader thing, you kind of have to provide how to stack it on top of all of the other ones because you cannot, like, you can't just swap the order. So if there is a thing that already knows how to stack on top of other monads, it will not necessarily, like, you have the n squared problem of, like, every new monad you add, you have to extend as much as possible. Like, you have to extend all of the others because the order matters, basically. FX systems want to answer that kind of problem. Yeah, no, I'll have to think about it off stream because I will probably have to try things and I will probably have to, like, decide how I want to do this. For this evening, I'm just going to remove this thing and accept the fact that for now I have something that's not great. I'm okay with that. Primitive goes away. This goes away. This goes away. This goes away. This goes away. This, however, remains. This remains with one exception. The exception being that there's no longer a lift, there's not a lift prim or anything like this. This is purely VI validated, VS validated is modified by doing insert of the base name. There we go. So this stays. This goes away. This goes away. This goes away, but this stays. That's a bug we have fixed earlier this evening. This stays as well. Okay, you can go away. You can go away. I think for context, everything goes away because that's the only thing we have changed. Perfect. For instantiation, we've definitely changed a few things. We've removed the to-do here, okay? So this can stay. But this goes away. This goes away. This goes away. This goes away. I'm keeping the diff. Wait, no, it's still there. Perfect. There we go. Validation monad. I think everything here goes away. I don't need primitive. I don't need strf. The type here no longer has prim state. Yeah, all of this goes away. So I can just remove that. And as a result, I think this one is also... Yep, this one is also just going away on its own. There we go. And I can also remove primitive in the dependencies. Okay. So now we're back to... we will get some errors duplicated, which is fine. Capture the calls and run another monad on top that emulates the lower monad by redirecting. I could do something like this, in fact, yeah. I could run a second monad diagnosis on top of the first. And when I run the validation, run the diagnosis, and then just throw to the underlying diagnosis monad the result of the top one. That's also a possibility. Why do I still have a control monad primitive? I shouldn't. Oh, I still have a bunch of prim monad there that I have missed. Okay, this file I modified a bunch of things, so this file I'm gonna have to make the diffs manually. Because that needs to stay. This goes away. This stays. This stays. Except this is gonna have to be replaced by, yeah, okay. I hope I didn't remove too much. We will see. Okay. I might not have removed enough, in fact. I might have removed too much. Because that function is no longer in scope. Yep, I have removed too much. So let me do that. And just for this file, go back to when I started putting there we go. And now that should be fine. And now we were back to before doing this experiment, where again the only bad thing is we are checking some things more than once. We will throw some errors more than once. Not the end of the world. But yeah, as you were saying, I think another potential approach would be to, rather than require this monad M to be a monad diagnosis underneath and throw to it, I could instead, since I need the state to be persisted, I could here have this be a diagnosis T on top of that. Run diagnosis in this, so short circuit on top there. And when I run the validate T here, I get the diagnosis and I put them back in the one under when I'm done. That's also a possibility. Which is a bit ugly, but not the end of the world. And might actually be the best solution. I could even consider, if I do this, I could also even consider not running validate as being a transformer on top of some other monad, but being purely this and running entirely in memory, not being on top of something else. which means I always run validate and then I get the result and I have to put it back. That I think would be the best approach, probably. Because that way I don't tie this particular operation, which is all in memory anyway, to some particular stack of monad in which I'm operating. This might be better. I'm probably gonna do that, I think. I'm not gonna do it now. Or do I do it now? I'm gonna commit what I have. I'm gonna commit what I have, and then maybe I do it. Or did I change? Oops. Oh yes, I did change that, yeah. Okay, so let's commit this as part of the refactor. I haven't merged the branch back. I'm gonna commit this in an ugly way because we are still trying to finish the refactor technically at this point. Again, until I have reached a first version of this working, I am okay with commit messages not being great, and I'm currently in a branch that I'm gonna merge back into the dev branch. That's fine. This is the worst commit message I've ever written, or close to it, but at this stage, I'm okay with it. When we start having a compiler that works and we start doing iterations with like new features, with like pull requests, like proper pull requests, and like proper changes, then we will put some effort into the commit messages, but we are not there yet. Okay, so if I do that, if I do this change, then validate T goes away. I have validate instead, and it is a diagnosis T on top of a reader T on top of a state. And now that means that running this thing, aha, I could do it this way. Given that I have some monad diagnosis underneath, I get a validate of A, and I return this computation by running it in memory. But that means I will need to have a way when I do monad diagnosis here, run diagnosis T. In fact, I will want to get brackets back if I do this. I will want finally again. So here when I run diagnosis T, it gives me a sequence of diagnostic and maybe of a value. I have this notion of ensure that is able to, okay. So I will probably want to also I will probably also want to how do I call this? Digest, which will ingest rather. How do I append? Let me just have a quick look at how I run in the analysis here. I do validate, and this might short circuit because validate, which is defined in validation here, now I just run a validate t. This will try and instantiate all symbols. If I remember correctly, instantiation. Okay, so this one does not fail. This one does not fail. So yeah, I think I will want... Okay. So let's do this. I will add another capability. If a monad has the capability of being a monad diagnosis, it will be able to relay, ingest, recover, no, subsume, send is to generic, forward is to generic. What is the verb that I want here? Where I want to forward the errors that have happened before in a broader context. Report. The report is already used. What is the verb that I want here? Integrate? That's not a good term. That's too generic. Continue. Continue isn't great either. Am I using this word correctly? Yeah. Subsume, absorb. What would be the right verb for this particular thing? Where I want to continue reporting errors within a scope that's different from the one I had before. Which is basically report a bunch of diagnostics and then yeah, let's use subsume just because it's specific enough. So this will be a case where I have a sequence of diagnostics and I have a maybe value. In fact, I'm going to change something here. I'm going to say that if I ever have I don't need to do that here, suppose. But yeah, I wouldn't know. I need to do that. I need to do this and here in ensure. I have a thing that's like, was there ever any error? This needs to be set to true if I use ensure anywhere else. Okay. So that means how do I write this actually? Without it being because this is indeed a hoist maybe. That's what I want to do. I have maybe a value here, and I want to put it in the diagnostic thing, but I also want to, I guess, is there a when nothing in control monad extra? There is a when just, there is a when maybe, there isn't a when nothing. But I suppose that when nothing is already handled with monad plus. Monad plus. Where's the define again? But that's. I guess I can do just with the when. When is nothing the maybe value. Set ds any error to true. And then hoist maybe the maybe value. Okay. And then we need to do a subsume that given a bunch of diagnostics and a maybe result will do append those diagnostics to the inner list. This is gonna be, it's a sequence. What is the operator for a concatenation of sequence? It's just gonna be, so it's gonna be this one. Diagnostics, and then ensure the maybe value. Subsume for any monad on top of diagnostic is just lift of subsume, which means back in monad, validation monad here, run validate t, given that we are on top of a monad that has diagnostic capabilities. I run this thing in memory. Which gives me a value. So first I run diagnosis t, and then I run the reader, then I run the state. When I'm done, I am left with this validate state and value, which is my result. But since I run the diagnosis first, before I run the state, I am gonna be left with this is going to be the result of this. Since the state happens last, and I can remove the swap, I will get here first the result of my computation, which will be the tuple of diagnostics and maybe this A. So diagnostics result. And here I'll have my state. That's the result of doing this. And with this, I can do a subsume, which requires first on the left-hand side the diagnostics. And here the value I want to return, which is going to be the state at the beginning of the result. Okay. And now that means that everything is broken, but that's fine. So what I'm doing now, sorry, I had missed your message. I am doing something that is very close to what you were suggesting, because I think that is the right approach, which is rather than having validate be a validate T on top of some kind of monad M that happens to provide diagnostics, I'm putting the diagnosis monad on top of everything else, so the state will be persisted properly in case this one short circuits, and I'm rewriting this top level function to be saying, okay, we run this one completely in memory. It doesn't touch the underlying monad M, whatever it ends up being, but the underlying monad M happens to have diagnosis capability. So if this fails, we relay the failure on top of the other one, in the other one, which is kind of what you were suggesting, but I'm doing it in a way where I'm not stacking things on top. I'm just running everything in separate stack and then converting back into the main one, which I think solves all of the problems at the same time. The downside of this approach is if I ever want to be in a unified application stack that all of the code operates in, well, now this part of the code operates in a separate stack that is purely in memory, doesn't have access to it. That's fine, I think. That is fine, I think. So, what has changed now is that every single function that says validate T is now wrong. So, how do I do this? I'm gonna do it in a separate Emacs, I think. Let's do a git grep minus L of validate T of M. It's in all of those files. Let me put this at a size that's readable on stream. There we go. And now every single instance of validate T of M will be replaced by a validate. There we go. I'm gonna try any instance of monad diagnosis M will be replaced by this. I think there's one that's wrong that I need to fix now, which is the one in here. Because run my validate does definitely need monad diagnosis of M to be able to forward to subsume the errors back into it. Okay, let's see if this works. Maybe result. That is the wrong thing. This is supposed to be, of course, an M of A here. Could not deduce from that state diagnosis state. Oh, of course, I need this to be operating in the diagnosis T there. There we go. And that's the same thing here. Diagnosis T of, and there we go. Ah. But if I do... So no, okay, I'm going to do it this way. Okay. No M here anymore. Validate is purely in memory. It's diagnosis T on top of reader T on top of state. No instance for monad mask identity. Huh. Huh, that's interesting. I didn't consider that at all. That's fascinating. I guess that makes sense. I had used a few places like I used the bracket approach in a few places to make sure that if an error happened, we would catch it properly, rather than having to do a try myself. But I was relying on monad catch, which is meant to, you know, catch actual exceptions and do a proper finally in those cases. But when I'm on identity, this doesn't, yeah, this doesn't actually exist. Okay. Does that mean that I should write my own bracket for the context of diagnosis? That doesn't seem like a bad idea. The question is, how do I name this function? So, do I call this a... Because bracket is the usual name for this, but I don't want to introduce yet another thing called bracket. That being said, I can just call it bracket and be clear about my import otherwise. So this would be, bracket would be, I am in some monad diagnosis, whatever it is. I have a init function that action that gives me some A in my monad. I have a tear down thing that takes this resource and gives me some B value that I don't care about. And I have the actual body of the thing. And this returns the MC. Let me just check that this is the order in which this bracket is defined. Okay, it's defined, but with this order change, I can do that. Yep, okay. And bracket will be given some setup, tear down, and action will be a do of resource is obtained by doing the setup. Result is obtained by doing a try of the action of the resource. We then tear down using the resource, and then we ensure the result. Okay. And we can add bracket underscore, which is the same thing, except we ignore the A thing. So this gives me whatever. I just try the action. There we go. Which means that now I'm going to be using the bracket of monad diagnosis and not control monad catch. So this bracket is not the one from control monad catch. Wait, it should already be picking up this one. So with context in this monad, it should be using the one from diagnosis. Why is it saying that it's using... Oh. Ah, of course. Diagnosis. Here I need to also add monad reader r monad state s. So what I'm saying is, if there is derive automatically, if there is already a reader instance in this thing, then make this one a reader instance as well. Ah, this one I'm gonna have to write manually so I can bypass. Let's state S of diagnosis T of M, where get is gonna be diagnosis T of lift of get, and put is gonna be diagnosis T of lift of put, I think. Something like that. Okay. Here again, we seem to be looking for arising from a use of report error? Huh. Do I have something here that makes the assumption monad mask? Ah, yes, here I'm making the assumption that it has to be a monad mask for it to be a monad diagnosis, which is not true. Okay. Double redundant. Okay. This one is... Wait. Yeah, of course. I don't need the constraint of monad diagnosis M because I am now operating in validate, which carries its own monad diagnosis. Perfect. Ambiguous bracket, that means I still have an import of control monad catch. I can remove it. This is now the bracket of diagnosis. Oh, I could have replaced all of those monad M by has call stack instead. Diagnosis is redundant. I am purely operating on validate. Okay. So I still have some monad diagnosis that is around. Okay, so I'm going to just do the same thing. I probably have to do the same thing here. Yep, there we go. No monad diagnosis M. There is no longer any M underneath. Okay. Next, what do we have? Oral M when we don't actually have an M. Oral M when we don't have actually an M anymore. Ambiguous type, because I probably have a bunch of... I do indeed. Oh, excuse me. Okay. Ambiguous bracket. We remove the one from catch. Run validate T no longer exists. This is now run validate, which will throw this into... So this needs to be a monad diagnosis, because I will be running the run validate thing inside, which will short circuit then. Which will fail if this validation failed. And now with that change, which is a lot cleaner than the other old one, now I only have one diagnostic declaration, and we can try the complicated case that I was mentioning before that would be broken when I was using the pointer. if I have A that depends on B and on C, and B isn't... Ah. The problem is, like, if... Yes, B needs to be valid. And C needs to be invalid because it depends on D, and D depends back on C. With the pointer solution, the problem would have been I am validating A, I stack validating B on top. This succeeds, so I unstack B, I mark B as validated, I add it in my cache, all done. But then, while still doing A, C fails, then I unstack back to A, and the fact that B had been analyzed would have been lost. And with the pointer solution, worse, it would be labeled as validated despite the fact that the cache would be lost. Now, with this version, we should not lose the fact that B has been validated when A fails because of C, because now diagnostic is on top. And of course, I have an error somewhere. I am missing a semicolon here, because of course I am. And now I only have one error. And another way to test this would be if B has some kind of error, I should only see it once. Despite the fact that B is first perceived while stacked on top of A. I get one error for C, which is the cyclic definition. And I get one error for B, which is the wrong type. It bothers me a tiny bit that I'm seeing this error after this one. But it's not bothering me enough for me to... Actually, let me check something. No, I'm adding it at the end. So for some reason... For some reason, the error that happened when... The error that happened when I encountered B did not make it through this. Why did it show up as a second error? That's the thing I don't get. What if I were to go back to here and import debug.trace, my beloved? And whenever I get report of an error, let's trace show M the diagnosis and trace M debug first. To see if the state is lost somehow and in which order those things are thrown. So the first one is a cyclic definition. Okay, so it shows up first. For some reason, when I'm doing the constant, if I look at a constant, I have a plus sign, so an addition expression. So it's validate binary expression with. I'll try the left hand side and then I'll try the right hand side. Why do I get the error for the right hand side first? Hmm, that's weird. That's weird that I'm seeing this error first. I'm not expecting that. Because here I'm clearly doing a validate binary expression with, which will try to validate the const expression of the left hand side first, which would report an error. Yeah, no. I don't know why this is giving me this error first. That's weird. What if C also had the wrong type here? In this case, no, I get the error for C before I get the error for B. Huh. Am I putting them in the wrong order? No, I'm seeing this one first. How is that possible? I am confused. I am extremely confused. It looks like as if the order here was reversed, which makes no sense. So here, the left-hand side of my plus is the identifier C. The right-hand side is the identifier C? What? What on earth? What on earth? So this is on line 5, column 16. It's there, yeah, the end of this. This is a path expression pointing to C? What? Okay, so that's a pretty big bug. The question is, what's happening here? Is it that my resolve is wrong? So I am in an expression. This is an addition expression. I have a left-hand side and a right-hand side. I'm putting the addition expression on resolving the left-hand side and the right-hand side. I don't seem to have a place where I put the right-hand side on the left-hand side by mistake. What on earth is happening here? There is a possibility that my scope is wrong, I suppose. So let's have a look at that. Let's have a look at trace show M top level scope. What is happening here? Actually, this makes me really want to work on the pretty printer so I can actually debug some of that stuff. So the top level scope is here. That's this one. In scope, I'm gonna copy this and I'm gonna copy it into the scratch again. Let's try to see what we have. Is the bug in the scope? That's the built-ins. Okay, so I'm saying that the path main A points to a constant, which is the one that is at main and A. That makes sense. Underscore points to the placeholder. That makes sense. Main and C is something that points to a constant, which is main and C. That's correct. Void is a built-in type. A on its own points to main A. Yeah, I agree with this. Character points to the built-in type character. Main B points to main B. D points to main D as well. That makes sense so far. Wait, wait, wait. Do I have... Is that... I can probably print the different versions of the AST to see what's happening there. Because it looks like the scope is correct. Like B1 points to B1. No. The scope is wrong. Wait, no. No, B points to B. I misread. And C points to C. No, it seems to... The scope is correct. I can't find an error in the scope. So it means somehow I'm resolving this as the wrong thing. I'm resolving this B plus C as being C plus C. That makes no sense whatsoever. Okay, so more debug trace. So I'm gonna do a trace show M of the module info, I suppose. We'll get the past version of this. And here I'm gonna do a trace show M of the resolved definitions. I want to figure out why on earth we're pointing to the wrong one. So here, that's the module with the definitions. Okay, there is a constant definition here for A. Its type is the raw identifier int. And the constant expression is with location, yada yada, an addition expression of a path info, which is B, and a path info that is C. Okay. That's the end of the declaration of A. So A is declared as B plus C. That's fine. Now here in the definitions afterwards, A is a constant. Wait. Oh, that's a scope. That's the scope. And the definitions will be in this. A is a constant definition, the type of which is int, and the const expression with location, yada yada yada, is an addition expression of B, okay, and with location, yada yada yada, of C. So after doing the name resolving, the scope is correct. We do see this AST as being B plus C, okay, okay. But then, if that's correct, then what the hell is happening here? I have an addition expression, E1, E2. I validate binary expression with. Oh, God damn it. I was printing the wrong thing. So I was debugging the wrong thing. That doesn't help. And is it just then that those are reversed? Because E1 points to C. And E2 points to 1? Oh. Oh, is it just that the order of declarations... Is it just that the order in which I am doing the validation is not guaranteed? That's it. That's exactly what it is. I do get a hash map from base name to definition. So I'm not going to be doing the validation necessarily in order of the declaration in a file, which means the reason I'm seeing the C error before the B error is just that C happens to be validated first. That's what's happening. Okay. I got a bunch of error wrong type. So let's just remove all of those debug traces because all of those are wrong. Wrong. Useless. Okay. Not what I meant to do. Not what I meant to do either. There we go. Okay. And what do I have here as errors? If I go back to this, I'm expecting to get, so diagnostic, I have an error. So for C first, just because the hash map doesn't guarantee that we were going to process thing in the order. Do I want to fix that actually? Do I want to use, instead of a hash map, do I want to use an in a hash map that preserves the insertion order, or just a list if the output of the resolve is fed directly into the next phase anyway, so that I process declarations in the order in which they appear in the file, which will make a lot more sense in terms of errors presented to the user. Um, I already get them as a hash map from the scope. So I would need the scope to also give me here I would need past local declarations to give me not a hash map base name pass definition, but a list. Which is taken from a hash map where I use the key, the identifier key, as a way to deduplicate entries. So I would need this to be an insertion order preserving hash map, which then finally would give me at the end, I get the resolve definitions, and I just pass them to validate. And validate takes the local definitions, puts them in the state. So I would need to change a bunch of stuff for that to be the case. I think it's worth it. So this is supposed to read video feed here. Let's fix that. I'm going to commit what I have, which is put diagnosis T on top, invalidate. And now I'm gonna go back, and I'm gonna go back to scope. This function, pass local declarations, will not give me a hash map of a base name to with local pass definition. It's gonna give me, how is it called again? With package down. It's not. This is going to be an int or the hash map, which is the thing that do I have a dependency on? I have a dependency on ordered containers, which is not the same thing as insert ordered containers. Wait. Yeah, I have a dependency on this one, not the other. This one was last updated last year. This one 2022, but seems to have more. No, I think ordered containers is fine. The one I have. It's just going to be a map ordered. Not a hash map, I suppose. Which should be fine. So So scope here, I'm gonna need to have import data. Is it ordered map? Data map ordered. I'm gonna also import the OMAP type. Which means now pass local declarations gives the local declarations to me as an OMAP. Which means this is an OMAP. Which means this is an OMAP. I don't need to qualify it that way. In fact, I mustn't. So now this is a map that preserves the order, which means that then when I do my resolution, I am doing a for with key that doesn't exist on OMAPs, I'm sure. Is this even a traverse with key? There isn't. Okay, that's annoying. Which means I'll do a OMAP from list. And this is going to be I'm going to be doing a for over OMAP associations of the definitions, which will get a tuple of the declaration base name and the definition. There we go. Which means I need to have OMAP in scope. Okay. So now the result will be a map that has preserved this order, which means this will be, oh, it's past midnight already, will be an OMAP. Again, I'm gonna need to have the name OMAP in scope. Okay. Now that means that validation needs to take as an argument an OMAP base name to the thing. So here, likewise, data set at a map ordered as OMAP, but also import the name OMAP so I don't have to qualify the type. For with key of the local definitions doesn't exist. So this is going to be again a for of OMAP assocs of the local definitions. And when I do that, I'll get, instead of 2 arguments, I'll get a pair. The rest of the code remains the same. Okay. And that means, last but not least, that if I go to my monad here, local definitions will need to be an OMAP here as well, which means I will need to do the same thing here. And probably the last thing will be, where do I use VI local definition? In context, I know, but where else? Only in context, okay. Okay. And only once, which is nice. That means I just need to look up local. So there's going to be a view thing, and here it's going to be an OMAP lookup instead of a regular lookup, which means I need to have data map ordered qualified as OMAP in scope. Okay, and now I should get the declaration processed. In fact, I'm gonna put a trace on this to make sure. In validation, if I were to put a trace M on here, trace show M of trace M of debug and show the base name. I'm expecting to have them appear in the order in which they appear in the file. Despite the fact that we've been going through hash maps partially for deduplication reasons in the process. Aha, here I have another, so this is also an OMAP lookup, which requires also to have data map ordered qualified as OMAP in scope. This compiles, it seems, so far. Nope. I am doing a for with key on the top level bindings. So that means this needs to be a OMAP as well. Everything else remains unchanged. However, for with key is something that doesn't work, so I'm going to need to do the same thing again of doing a for on the association list of that thing. Which will give me a pair instead of 2 arguments. And the result I will need to make back into a hash map, well, a map. Why do I need the identifier? Because I need it for the error messages, and then here I return identifier. Okay. Oh, are you serious? Ordered doesn't have from list with. Doesn't have from list with. Uh, should I switch to the other implementation of? Which tries its best to remember insertion order of elements. Does it have a from list with in the first place? No, it doesn't have a from list with in the first place. Okay, I'm giving up on this. Yep. It'd be better to be able to do that, but it's frankly gonna be a nightmare to do it in this current shape, so I'm not gonna bother. Something I could do, I suppose, is to keep the list of the definitions, and when I'm doing the validation, instead, okay, I have a hash map, but I could be iterating over the list instead. I guess a list is good enough. I want a hash map. I want to be able to do lookups of I have a base name, give me the corresponding thing. So keeping a hash map, transforming on hash maps makes a lot of sense. I think it's fine. I think I'm trying to optimize something that is completely irrelevant to what I'm trying to do in the grand scheme of things, which is having the error messages be in the correct order. No one cares at this point in the project. It will be important to have at some point. For now, it really doesn't matter. So maybe I shouldn't care. We fixed the problem with the diagnosis. That's already pretty big. We could do the same thing for the other monads, I suppose, which we might want to do at some point. So what do I want to do next? Oh yes, I would like to remake the pretty printers. Because if I remake the pretty printers, then I can re-enable some tests that have been disabled for the moment. And I can start having some more reliable testing of the whole thing. Yeah, I think I'll want to do that next, working on the pretty printers. But maybe it's past midnight. Maybe I should stop for this evening. We have done some work that's been useful, even though it's been a bit more chaotic this evening. Because we have found a few big bugs and we fixed them. We've made function pointers work as far as the analysis phase is concerned, which is pretty decent. We've made instantiation of functions work, which is also pretty good. We've improved a bunch of error messages. Come to think of it, okay, I'm gonna do one last thing. I'm gonna fix this order of definitions thing. I have an idea for how to fix it. I have an idea for how to fix it. So if this gives me instead a list of tuple base name with location path definition, I can put those in the same order that they were. And the definitions list, which is going to be the result here, which is going to be our association list that preserves the order, base name and with location thing, rather than being done from the validated bindings that will check that everything is correct. If everything is correct, if we know that, how do I do this? I'll have to iterate on this thing and recreate. So I'm just going to recreate that basically. Which duplicates a tiny bit of work. Where do I create the base name? No, that's wrong. I need to be careful. Okay, so I will go through the definitions. I will go through the identifier, and I don't need the role. I'm just going to call that again for the definition, and I will return pure of the base name based on the identifier. And the definition, which is really duplicating this, but that's fine. Wait, I am making it no, I want this to be this way. It's a bit ugly, but it's fine. It's negligibly ugly. So now I have a list of tuple, base name and with location, which means that when I do my resolution rather than doing a for with key, this is purely a regular for where I have a tuple. And I will get here in the output a list of tuple base name with location definition. I get that as a list. Which means I need to return here the declaration base name as part of the value. There we go. So now I have a list that is still sorted by the declaration order. Then, in validation, I can get that as a list. in the same way. And here I make a hash map out of it for future lookups. And here I can do a regular for local definitions, get the pair as an argument. There we go. And I can even rewrite this as being a traverse. This is a traverse of try nested of uncurry validate definition of the local definitions. There we go. And now this is a hash map, but I've taken the thing as a list. So now the order of error messages should be the same as the order of declarations, whenever this works, of course. Definition map no longer exists. This is a definition list. And the price of tiny bit more duplicated work in the scope, which is fine. Now I get the error for B before the error for C. Because now everything is passed as a list, which is fine because I'm not doing any lookups. I'm always just traversing it. And I just create it as a hash map for the cache within the validation. Okay, so that's perform analysis in declaration order. Okay. Yeah, okay, I think the next step is really pretty printing. I really want to be able to pretty print some of my ASTs under the different forms. I will want to pretty print annotated ASTs as well, which I didn't have before. But being able to print the parsed version, the resolved version with like a comment saying like, hey, this thing pointing to X, that is what it is, and printing a version that has type annotations would also be good. Although I don't know if it makes a lot of sense to. No, I think I'll want to be able to pretty print most things. So I think, yeah, that's going to be the next stream beyond the advent of code will be we redo the pretty printers, which allows me to then re-enable a bunch of old tests that are currently broken. Then we redo the simplification phase. And then we can go back to either more cleanups here or the IR. Simplification, I think it's mostly done. Takes an interface, returns an interface. The only thing that we simplify is the symbols. Yeah, all of this should be correct. Do I have a plated instance? Do I have a plated instance for my expression type? I do. Perfect. So it should just be a rewrite. Wait, do I have it on... I have it in expression. Okay. Oh, wasn't that the thing I had done before? I had done... I had done the plated instance not on expression, but on typed expression. Because I will want to change. Yes, I think I want to change that. We can do that. Let's do it. I think I will want to change this to be an instance of plated on typed const expression. And here it's going to be an instance of plated on typed expression. I think we do this still. Yes, this was wait, no, this was not an expression. Huh. No, we did an expression. Interesting. Oh, but they used to have something called typed expression, and I had my instance of plated on it, I think. Yeah, that's what I had. I had plated typed expression. And I need to get rid of all of this code. But yeah, I think I want to I think I want to make my plated instance on the typed version, not on the underlying thing. So that I can manipulate the type as I'm. Yeah, I think I was using this in the simplification phase. Yep, that's what I was doing because I need to replace the whole thing. Yeah, okay. I think that makes more sense. So it should be more or less the same. But instead of doing plate F and just doing the case on the argument directly, this is taking a typed thing. I'm going to deconstruct. The result of this will be typed with the type info F mapped into case of the typed value of. I can just probably copy and paste that. Although I suspect that I will have to remove one layer of traverse. Because before I was traversing the typed thing and now I don't. So this becomes just f of the left-hand side, just f of the right-hand side. Just traverse here. Here we have the same thing. Traverse goes away. Traverse goes away. Traverse goes away. Okay. Now that I have plated on this, I will have to make sure that I don't do traverses through typed there again, but I can make instances of simplifiable on the typed version. Okay. And And simplify will be something along those lines. It will be a rewrite of a typed expression where when I get a typed expression, I look at the actual value, which is typed value nowadays, and I can do that. Okay. So if I have an addition expression, yep, and the left hand side is an int literal the other one is an int literal expression. Oh, I'm using those int expressions to pattern match on the typed thing. I probably want to keep that, which means I will probably need to introduce some type patterns. I think I no longer have any patterns at this point. I have the int name ones. I might still have them in the old code that I haven't removed. Stages, analysis, old. Ah, I'm surprised. I thought I had still had some more. Okay, so no, I don't. I suppose I could do it. It's gonna be useful anyway, so might as well. So a pattern of an int exp. What's the syntax again? That's a typed expression. And int exp is typed of int type of an int literal I think it needs to be, if I want to go even further, given how I was doing it, it's something that associates to an int a typed expression, and int expression of n, or I suppose, is an int literal expression of I. Okay? I can do that for character expression. And Boolean expressions. That will cover a lot of ground. Okay, that should be enough to get started. L values don't have anything that requires patterns. However, the const expression, I could probably do the same thing. Where I have a pattern that matches those const constructors. Okay. Random expression for now is ID. L value expression is ID. There's nothing to do there. This one will now overlap with those ones, so I'm going to have to remove this. I'm going to write an instance for list, however. So now, if I have, I call them, maybe I'll go back to calling them expression, with the idea of exp being the constructors. Well, no, the whole point is that this simulates a constructor. Maybe I'll keep this. So if I have an int exp of 0 on the left-hand side, I can replace with the left-hand side. Okay, so it's the same kind of thing where I can't short circuit there, not at this point, but I can remove things that will result in no computations at all. For instance, if I have a Boolean negation of a Boolean negation, there's no point. Okay. And that should be it. That should be enough for the simplification phase. And now the only thing is how much of this applies to a const expression. Const expressions are only literals. So no, there's no simplification phase for a const expression. So I can just... const expression is ID. I could probably just remove those and make sure that I don't call simplify on them. It might be easier just to keep the ID there and... Okay. So is this working? It's not. Because I will need... Oh, pattern synonym is already enabled. Okay. It's not an int, it's a character. It's not an int, it's a boolean. Character boolean. Oh, this is still a traverse. Still a traverse 2. Oh no. Was it already correct? Have I broken it? So this is still a traverse. Okay. So X per value is something that no longer exists. This is another lens. This is the typed value lens. Wait, is that not the thing of typed validated? Is typed defined? Oh, did I forget to make the lenses of it? I have indeed. That explains. I seem to just actually be doing the simplification phase, which wasn't planned for this evening, but oh well. No instance for simplifiable maybe, so I need to do that here as well. With location, okay. Could honestly just do F maps for the whole thing, but it's easier to just oh, range expression is not typed. It doesn't matter. Range expression isn't something I have to simplify anyway. I think. So I'm just not gonna even attempt. I'm just gonna return it unchanged. Okay. So that's the simplification phase fixed, which means I can go back to main and I can plug it there. This is simplify module of this. Go back to my main test file and I remove those broken constants. I want it to succeed and I want it to be simplified. So let's introduce a function foo again. Turns an int, takes an int. Oh, I think I had in test 3. I think I had a function for to test this. Oh, I did not, it seems. Oh, no, there we go. Baz. Which does 1 times 1 times not something that can be computed at compile time and something. Which, so true and something will just be the something as int plus 0 plus 0. That should be. Do I replace the cast? I could be replacing the simplifying the cast when the cast is of the same type as the thing. Okay. So Baz has been simplified to it's a return statement, that's correct. That is of type int, and it's a cast expression from an expression that is a boolean, which is a boolean and of true on the left hand side. Okay. And the lesser expression 1 and x on the right hand side. So it is just true and that. So I did not simplify the true, interestingly. Despite the fact that I do have a match for Boolean and expression of a Boolean expression true. Is my pattern wrong? Because this should have matched. Oh, unless I have an error in my pattern. That's also a possibility. That's not what I meant to do. I meant to go back here. Yep, I have an error here. This is a Boolean type here. And I'm assuming I have the same mistake here. That is a Boolean type here. If I try that again, now it should be replaced. The simplification phase should have replaced all of this nonsense by the value of the whole thing is a cast expression of a Boolean value as into an int, and the value is a lesser expression of 1 and x. That's the only thing that remains of all of this. The simplification phase is fixed. Okay, and I'm gonna stop here for the evening for real this time, rather than taking out one more task and then adding more stuff. I'll add here, remove the type base name from type parameters. That's correct. I need to do that. Making function argfunctor will be such a relief. Remake pretty printers move first, I think. Remove changed resolve t to be like validate. So that I'm gonna move the diagnosis t on top so that if there's any state, it's persisted, and then it's all in memory, not on top of another stack. And then I just put it back, I subsume it back into the underlying diagnostic monad. And after all of that, we will go back and fix the IR. I'm sure there are other things I have to clean or debug in the meantime. But that's the plan for when we're not doing the advent of code. Okay. In the meantime, I'm gonna go for the evening. I need a break. Thank you everyone for tuning in. It was a weird one this evening, but we made some progress, which is always good. And I will see you next week for the advent of code first, and then more of the compiler. Have a good weekend, everyone.